Like, where are my glasses? And now on my head. All right, so question. Write the equation for the slope of the curve for any point x, y. So calculus, what are we going to want to solve for? We're going to want to take the derivative, but what are we trying to get by itself? Good. So my slope, dy dx, is going to equal the slope. So my goal is to try to get dy dx by itself. Oops, sorry. Is try to get dy dx by itself. So this is implicit. So let me start with the function. And now let's take its derivative. Derivative of x squared, 2x. Now I'm going to take the derivative of a product. So here's the product rule. Derivative of the first, which is x, that's 1, times the second, just y, plus the first, which is x, times the derivative of the second. Good, that's where dy dx comes into play. Plus, now I'm done with the product rule, I move to y squared. Derivative of y squared, 2y, dy dx. Anytime you take the derivative of y, you have to have that dy dx as that attachment. Equals 0. Good, 27 is a constant, so it's 0. So remember, our key from the beginning of the question, we said we need to get dy dx by itself. So the first thing we do is we want to isolate it and then factor it. So we isolate it by moving, how do we get it by itself? Yeah, I'm going to move these guys over to the other side. That's going to leave me with x. Actually, you know what? And you can do this in the step. I think you're ready for this, and I've done it before. I'm isolating the dy dx's so I can do what to it? Factor it out. So that's what I'm going to just do it all in one step. So there's my dy dx times what was multiplying it here, x, plus what was multiplying it here, 2y. And then I moved to the other side that 2x, and it became a negative 2x, and the 1y, which became a negative y. So you can do that all in one step if you want, because that's the goal, is to isolate and then factor it out. What do I divide both sides by? Yep, x plus 2y, because we're looking to get that dy dx piece out. So dy dx is going to equal negative 2x minus y divided by x plus 2y, and that's what they wanted. They wanted, write the equation for the slope of the curve at any point. There it is. Questions? All right, part B. It says determine whether the lines tangent to the curve at the x-intercept of the curve. Determine whether the lines tangent to the curve at the x-intercept of the curve are parallel. Okay, so we have to first talk about x-intercept. How do we find an x-intercept? Good, we're going to let y equal 0. So we'll let y equal 0. Remember, here's my equation. If I let y equal 0, what's going to happen to this part? 0, what's going to happen to this part? So what am I only going to be left with? X squared has to equal 27. How do I get x? Square root. X is going to equal. Now, here's the thing. If I have to take the square root as part of the solution, I have to put plus and minus. How can I simplify the square root of 27? Good. 9 times 3, which becomes 3 radical 3. So I have two x-intercepts. That's what they were referring to. So if I have two x-intercepts, tell me one of the points I'm going to be looking at. 3 square roots of 3, comma? What's that? 0. Good. If it's an x-intercept, the y-coordinate 0. Then the other the other point would be what? Comma? 0. Okay, so again, we got to just keep going. How are we going to keep going? Well, we're going to take the x-coordinate and the y-coordinate and plug it into my slope, because that's my point, right? So I have to get a slope, so dy dx. Do I have to actually find the actual equations of the tangent lines? Are they asking for the actual equations in B? Just determine whether or not they're parallel or not. So would you agree that if I just take this point and plug it in, and get an answer, and then take this point, plug it in and get an answer, they'll be parallel when the slopes are what? The same. So, and all we're trying to do is determine. So I'm going to find the slope, and I probably should put this in there, 3 square roots of 3 comma 0. So that's what I'm going to do first. Let me raise this up. All right, so now let's calculate that. So it's going to be negative 2 times the x coordinate minus y, 0. X will be in the bottom, 3 square roots of 3, plus 2 times y, which will be 0. So simplifying this, I'm going to get negative 6 square roots of 3 over 3 square roots of 3. And they're dividing, so this is going to become what? Negative 2. Oh, kind of a nice answer. Now I'm going to go down here, and I'm going to go negative 3 square roots of 3, comma 0. And I'm going to plug in. So dy dx is going to equal. And I'll let you guys work ahead a little bit, and I'll be quiet. Do the same thing again. So what did the slopes turn out in both cases? Negative 2. So if they are, you can say since the slopes are the same, since the slopes are equal at the x-intercepts, the tangent lines are parallel. Questions on that? So that, again, right now where you guys are and in terms of the midterm, just do the best you can. Don't beat yourself up when you're taking the midterm. Some of the stuff you're not going to be, I know you know the calculus involved. You might not be able to get through the question to kind of get to the calculus. Just do the best you can. These questions are going to be asked. I'm hoping you can see it's doable, but if you're not there yet on this midterm, don't beat yourself up. The midterm is curved, so just make sure you get through it. You get through it. Do the best you can. Okay. And then part C. I'll just stick it right here in the middle. Part C. What does C say? Find the points on the curve where the line tangent to the curve is vertical. So now, again, everything we've been involved with is slope. So tell me something about this slope on vertical tangent lines. Okay, when it's undefined, the bottom has to equal 0. So here's my slope. The only time I can have vertical tangent lines is when this thing becomes undefined, which means what has to equal 0? So x plus 2y has to equal 0. So that's going to be what x is going to equal what? Negative 2y. All right. I'm not done. What's our original equation? X squared plus xy plus y squared equals 27. And I'm looking for points on this curve. So what do I know? I know that any place on this curve that satisfies x equals 2y, I'm going to have a vertical tangent line. So can I now substitute? Yeah. So I know the value of x. So what am I going to put in its place? All right, so negative 2y squared plus x, which is negative 2y, times y plus y squared has to equal 27. Oh. All right, so how can we, what does this become? 4y squared. This becomes negative 2y squared plus y squared equals 27. Yep. So you're going to have 3y squared is equal to, this works out to be so nice. Don't, just the hair in the back of my neck is standing up. I'm getting so excited. What do we do? Divide by
3.
Yeah, you know, this is now, you're in my world, this is all working out. Oh, why, so we do all this work and it comes out to be this? You should feel pretty good because what's y? What's y? Plus and minus 3. Okay. Now again, we're not done because what's the question say? I know we are, bell rang, but what's, find the points. So what we have right now is we have this, comma 3, comma negative 3. So you're going to take this 3, you're going to plug it back into the equation for y, and what's that going to leave me with? An x. So solve for x. Then you're going to do the same thing with negative 3, and then that would be your answers. Yeah, there's a lot of work in each of these questions, but okay? All right, we'll continue with the other ones tomorrow. All right?